Hello everybody, welcome to the next math video. As you can see from the top of the page, today we are going to be talking about slope and rate of change, two topics that are very important for algebra. So let's just dive right in and start working on these two important concepts. Okay, so for this first part, I want you to just take a moment and pause the video if you need to, and on your sheet, I want you to put down what you think positive slope looks like, what you think negative slope looks like, and what you think a slope of 0 looks like. I want you to do this. I'm actually not going to fill these in, but coming up, I want you to compare what you thought was correct with what is actually correct in this next section of the notes coming up. So just put down what you think they are, then we're moving on. Okay. So, how to classify lines by slope. Here we have the descriptions of the different slopes: positive, negative, 0, and undefined. In a positive slope situation, what we're going to notice is that the graph goes up from left to right. So if these are our axes, a line with a positive slope could be this. Or it could be this. Notice that both of those lines, as you go from left to right, are increasing in the y value. A negative slope is basically the opposite. It goes down from left to right. So, axes again. This could be a line with negative slope, this red one I'm drawing now. Or we could have a steeper line with negative slope, this blue one. Notice that as we go from left to right, the graph is going down. Next, we have lines with a 0 slope. We've seen these, actually, we saw these yesterday, and those are your horizontal lines. So, put the axes in. Of our horizontal lines are lines that go straight left to right. So, this green line, or this blue line, those are both horizontal. The x-axis is horizontal too. And lastly, undefined lines, lines with undefined slope, are vertical lines. Axes. So this red line will have an undefined slope as long as it's parallel with the y-axis, and so will this blue line. So those are the different slopes that we can have. We could have positive ones, negative ones, 0, and undefined. Now how do we calculate slope? Because there is a way to do it. That's what we're going to look at coming up right now. There's an equation for it. So we're given 2 points, and the way I'm going to label these is, we know that we have x coordinates and y coordinates, right? X and y, but we need to make sure that we know which one is which. So what I'm going to do is, for the first point, I'm going to put little 1s next to the number, and for the second, I'm going to put little 2s next to the number. And now we have x1 and y1 for the first point, and x2, y2 for the second point. If we have that, then the slope is going to be calculated by taking our y's, usually start with y2, and finding the difference between them, and dividing that by the difference of the x's. So, that's how we get our slope. So let's look at this in this problem down here. Let's say that this first point is x1, y1, and the second point is x2, y2. We're going to plug things in where they need to go then. So y2 is 6, so I'm going to have 6, minus, and y1 is 4, so I'm going to have 4, divided by x2 minus x1, so we have 3 minus 2, equals 6 minus 4 is 2, and 3 minus 2 is 1, 2 over 1 is 2. So that's a positive slope. So we would expect that the graph that contained those 2 points to go up as we go from left to right. Let's flip the page over to see more examples. Find the slope of the graph. I will tell you, this is hard to do without measurements. You can really faintly see lines on your paper. They're kind of hard to see though. But what I'm noticing is that we have basically 1, 2, 3, 4, 5 boxes going down that way. And then going off to the side, I see 1, 2, 3, 4, 5 again. And then we get to that dot there. Okay, so what we need to do is find the coordinates of these points. This one that I'm going to fill in with red, we see that it's right on the center of the x-axis, so it has an x value of 0, and to get to it we have to go down 5, so the y-coordinate is -5. We also can find the coordinates of the other point. I'll mark it in blue, and we see that we have to go to the right 5, or to the left 5 I mean, so that's -5 for x, and we have to go down 3, so that's -3. So, now that we have our points, we can find the slope. So we just need to choose one of these points as x1, y1, the other one is x2, y2. Let's call this one x1, y1, and we'll call the one in red x2, y2. Okay, so now we just do slope. So we'll have -5 minus -3, and then we have to divide that by 0, which is x2, minus x1, which is -5. So notice that we have a lot of minus negative here. Remember that minus negative turns into plus. So what we really end up with is -5 plus 3 over 0 plus 5. That would give us -5 plus 3 is -2, and 0 plus 5 is 5. And that's our slope. Notice that we would expect the slope to be negative because the graph is going down as we go from the left towards the right. So it should be a negative slope like we see there. Alright, on this one, we could do more work, but we've already learned about Hooivaks, and we see that this is a horizontal line. So when you have a horizontal line, we know that the slope is 0. So the slope of this line is 0. Don't even really need to do the slope equation for that one. But you could, and it would still give you 0. Last example, rate of change. This table shows the distance a person walks for exercise. Find the rate of change in distance with respect to time. Okay. So distance over time basically is what that's asking for. So distance with respect to time, this means distance over time. So we just need to find the distance over time that's happening here. So if we go 1.5 miles in 30 minutes, well, we just have to calculate that. 1.5 divided by 30, and you can use your calculator for this, and you'll be good then. But you should be getting let's see, 0.05, and that would be 0.05 miles per minute. And we should check the others and see if it sticks. So if we do 3 divided by 60, well, 3 divided by 60 is 1 divided by 20. 1 divided by 20 is also 0.05. So we see that there is a pattern happening here. And really that's quite important here. We seem to be going at this constant rate here, which is good to know. So, thank you for watching this video. I'm going to just scroll this a little bit down so you can see what the assignment is. Right there at the bottom of the page. Let me circle it too. There you go. So, good luck with the homework. Thanks for watching.